today. What are the 4 great discoveries of modern science that prove God exists? The first great discovery of modern science is that the universe had a beginning. Where did it come from? Historian of science Fred Burnham has written, "The God hypothesis is now a more persuasive and respectable hypothesis than at any time in the last 100 years. The second great scientific discovery is that space and time also had a beginning. This discovery demands an explanation. It calls for a transcendent cause beyond the universe itself. The third great discovery of modern science is that the laws and constants of the universe have been fine-tuned for human life to exist. As physicist Fred Hoyle has written, common sense interpretation of the evidence suggests a super intellect has monkeyed with physics and chemistry as well as biology to make life possible. The fourth great discovery of modern science is the digital code embedded in the DNA molecule in every human cell. The 3 billion characters of precise information in the digital code instruct the cell how to build complex molecules to do the work so the cell can stay alive. Where did this specified information come from? It is compelling evidence of an intelligent designer for the origin of human life. My guest today, who will explain these 4 great scientific discoveries, is Dr. Stephen Meyer, who received his PhD in the philosophy of science from Cambridge University. He is co-founder of the intelligent design movement in the world and a senior fellow at the Discovery Institute. We invite you to join us for this special edition of the John Ankerberg Show. Welcome to our program. We're talking with Dr. Stephen Meyer, philosopher of science who got his PhD at Cambridge in England. Written a best-selling book, Signature in the Cell, that we've been looking at in past programs, DNA and the Evidence for Intelligent Design. And what we have seen is that if you look at the cell, you got trillions of cells in your body. Those cells are so filled with information, and we've looked at some of that information, and that screams for an intelligent designer. That's what the evidence shows when you look through the microscope. When you look through the telescope, which is where we're going now, I think you're going to see design there as well. But that's not the worldview that's at large. We've got new atheists like Richard Dawkins, who wrote The God Delusion, Christopher Hitchens, God is Not Great, Sam Harris, The End of Faith, and others. Richard Dawkins said, everything, whether here or other worlds, where you see intelligent design, it's not really an intelligent designer that's doing it. There is no intelligence out there. It's an illusion. Now, Stephen, when you were working on your PhD at Cambridge, you investigated that worldview and compared it to how science actually started. Talk about that.
Well, it's really been a kind of a lifelong journey in investigating these big questions and the relationship between science and the larger worldviews that we humans formulate to make sense of our experience. And what Dawkins is saying is that science properly understood undermines belief in God. It challenges belief in God. And his argument runs something like this. He says that the strongest argument for believing in God was always the argument from design. When Darwin came along, we came to understand that there is no design in nature, only the illusion or the appearance of design. And therefore, belief in God is tantamount to a delusion. And that's the title of his famous book, The God Delusion. What strikes me about that is just how at odds his perspective is with the perspective of the scientists who actually founded what we call modern science. If you go back to the period of Newton and Kepler and Boyle and Galileo and Copernicus, the period that historians of science call the scientific revolution, the concept of design, intelligent design, was actually part of the foundation of the whole scientific enterprise. The scientists at that time had a watchword or a kind of a motto, and it was the idea of intelligibility. They believed that they could study nature and make sense of it because it was intelligible to the human mind. Why? Because it had been designed by a rational intellect, namely, in their view, the Judeo-Christian God.
Give me a few examples.
Well, there are many scientists who had this perspective, but take, for example, the founder of modern biology, John Ray. In his book, it was actually titled The Wisdom of God Manifested in the Works of Creation, which was a paraphrase of a passage in the book of Romans in the Bible that affirms that from the things that are made, the unseen qualities of the Creator can be known, including His wisdom. You find this perspective in physics as well. In fact, it is a whole series of scientists that express this. Johannes Kepler said that we as scientists have the high calling of thinking God's thoughts after Him. What are we doing? We're perceiving the design, the order, the structure that He put into the universe, the mathematical harmony that was put into the universe. That was Kepler's perspective. I think this perspective reached, in a sense, a kind of magisterial epitome in the works of Newton. He wrote in both the Optics, his famous work on the eye and light, and in his most famous work of all, the Principia, he made design arguments. So many scientists assumed design. Newton wanted to establish it by the evidence based upon what you might call the fine-tuning of the arrangement of the planets in the solar system. He was aware that gravity provided a force that was being harnessed to keep everything going, but he also realized that the forces of gravity that were in play from one planet to another and the sun to the different planets were so complicated that it was very difficult to imagine how you could get all those forces to balance to maintain a stable orbit. So in the Principia, he actually argues that the best explanation of that fine-tuning of the planetary configuration is the design of an intelligent and powerful being with a capital B. Here, let me read you the quote. It's very elegantly stated. He says, "Though these bodies may indeed continue in their orbits by the mere laws of gravity, yet they could by no means have first derived the regular position of the orbits themselves from those laws." He's talking about what physicists today call initial conditions. They're finely tuned to allow for this system to be stable. Thus, this most beautiful system of the sun, comets, and planets could only proceed from the counsel and dominion of an intelligent and powerful being. This is Newton's argument in what is arguably one of the greatest works of physics ever written. It's right in the structure of his case. So it raises for me a kind of curious question when I listen to Dawkins, which is, how do we get from Newton and Kepler and Galileo and Copernicus, from those guys, with their perspective that design is not only necessary for doing science, but evident in the natural world, to these modern new atheists who say that science has shown there's no design, and therefore belief in God is delusional?
All right, Stephen, let's answer that question. How did we get from Newton to Dawkins?
It really is the story of 19th century science and what began to change. The first part of it has to do with a man named Laplace. He was a French physicist who wanted to show that you could do what Newton said you couldn't do, which was explain the origin of the solar system itself as a result of purely undirected natural forces without recourse to any designing intelligence. He wrote a book called The Celestial Mechanics that became a great classic in physics, in which he attempted to do that. He apparently was called before Napoleon to receive commendation for making French science proud as a result of publishing this book. And as the story goes, Napoleon tells him, what a wonderful job he's done. He showed up the British and wrote this great book of science. But he noticed that he didn't mention God in his scientific works, and yet Sir Isaac Newton had mentioned him on nearly every page. And Laplace is said to have kind of puffed himself up and said, "Sire, I have no need of that hypothesis." And we don't know if this is actually true, but it became emblematic of what would unfold in the 19th century as science explained more of these great events in the history of the cosmos, these origins events. Laplace attempted to explain the origin of the solar system. Lyell came along in geology and attempted to explain the origin of the great geological features as a result of the outworking of slow, gradual, naturalistic processes, whether the mountains or the canyons or what have you. Then Darwin came along and explained the origin of the new species from simpler pre-existing species. Scientists followed him, attempted to explain the origin of life, those we've talked about in previous sections of the show, not so successfully. But by the end of the 19th century, there was this perspective that that you could have a completely seamless naturalistic account of the whole of the universe, from the origin of the solar system to the origin of the planet Earth and the canyons, to the origin of life, to the origin of new species, even to the origin of man, as Darwin extended his idea of evolution to account for the human species. So it was a kind of a seamless naturalistic account. And one scientist has said of Darwin that he helped establish this materialistic worldview. Douglas Fatuma, in a standard evolutionary textbook, says, by coupling the undirected, purposeless variations to the blind, uncaring process of natural selection, Darwin made theological or spiritual explanations of life superfluous. He had no need of that hypothesis, just as Laplace had no need of it. So by the end of the 19th century, you have not only a series of theories about origins, you have a kind of comprehensive worldview that gives a full account of where everything came from without any recourse to a designing mind, to a creator, to God, any external agent of any kind. And so, that's how we got from Newton to Dawkins. And Dawkins, in talking about the new atheism, is really recycling the perspective of the late 19th century. So,
what is the materialistic worldview, and what is the scientific evidence that is starting to refute that?
Well, if you think about what we were talking about in the last segment, how the scientists of the 19th century had developed a series of ideas about how all the big things in the universe arose. They had an explanation, or at least so they thought, for the origin of the solar system, for the origin of the great geologic features, the origin of new forms of life, the first life. They had this seamless materialistic account. But if you were to ask a question about that, there was one unanswered question, and it was, well, where did all the matter come from in the first place? Where did all the particles and the gases come from that were necessary to build even the solar system? Well, that didn't bother scientists in the 19th century so much, because they assumed that the universe was infinite, that it had always been here. So if you want to tell the story of the cosmos, you go back from human life to simpler life, to the first life, to the chemicals out of which the first life was made, to the elementary particles, and those have been here from eternity past. And so the materialistic worldview could be summarized in a kind of a little credo that runs something like this. From eternity past were the particles. Not in the beginning was but from eternity past were the particles. And the particles arranged themselves and became more complex stuff, more complex chemicals. And the chemicals arranged themselves and became the first living cell. And that eventually evolved by undirected materialistic processes, namely natural selection, and that cell became more complex life. And those living forms eventually conceived of the idea of God. They became aware first and then conceived of the idea of God. So in the materialistic worldview, there is a place for God, but God is a concept in the mind of one of the evolved forms of life, namely us, but God has no reality, and what is fundamental, what is the thing from which everything else comes, is the particles, is matter and energy that has been here from eternity past. So that's a perspective that's not just based on certain scientific theories, it's comprehensive, and in that sense it's a kind of a philosophy or a worldview, a comprehensive way of looking at everything.
Very clear picture of the materialistic view. Now, let's get into the stuff. What's the new science that is destroying that?
Well, remember, one of the key premises then in this worldview is that matter and energy are eternal and self-existent, and then also self-organizing. But the fabulous, extraordinary discovery of modern cosmology is that the universe is not eternal, that it's not always been here, that time is not infinite in duration going all the way back. And what first made scientists aware of this was things that they were seeing through the telescopes, the dome telescopes that came on the scene in the 1920s. And this is a photograph of Edwin Hubble, for whom the Hubble telescope of today is named. Hubble began to work in astronomy at a very propitious time, right in the 1920s, as these great dome telescopes were being designed and created. And as a result of these telescopes, they could capture a great deal of light coming from the night sky, and we're able to resolve little tiny pinpricks of light that previously we couldn't make out. And before the 1920s, there was a debate among astronomers as to whether or not the Milky Way, the galaxy in which our solar system resides, was the only galaxy or not. What Hubble discovered was, first of all, that there were many galaxies in every quadrant of the sky. And I've got some photos of some, just they're absolutely beautiful. There he is at his telescope having a look, and he's got Spindle Nebula that he discovers. Some of these are some of his original photographic plates, Spiral Nebula, sketches that he made of these beautiful galactic phenomena. And now we know that as you look at any quadrant of the sky in which you choose to focus, and then you magnify that, this is what's called the Hubble Deep Field, even the tiniest little quadrant is just chock full of galaxies in every direction. So it's an immense and enormous universe. That's the first thing he discovers. But the second thing is even more significant philosophically and scientifically, and that is that the galaxies, the light coming from these galaxies, is shifted in the electromagnetic spectrum, from red to violet. It's shifted in the red direction of the spectrum, indicating that the light is coming from objects that are receding, that are moving away from us very fast. Some of your viewers would probably remember the Doppler effect, where wherever it was sound, if you have a train recede from us, the pitch of the train goes down. Same thing happens with light. If an object is receding, the wavelength stretches out, and longer wavelengths correspond to the red end of the spectrum. So light that's shifted in the red direction is indicating a recessional velocity. The thing is moving away from us. And what Hubble discovered was that no matter which quadrant of the sky we look, we find galaxies that are moving away from us. And that led to an amazing, amazing conclusion, which is that the universe is expanding. And it's expanding outward in all directions. It's a kind of a spherical expansion, if you will. And I've got a way of illustrating that, if you will. Okay. And this is a simple balloon. But the idea, if every galaxy is moving away from us, and if the further away it is, the faster it's going, which is something else that Hubble discovered, the only way to make sense of that is that the universe is expanding in a spherical way like this. In other words, as you're going in the forward direction of time, the galaxies are moving further away from each other, and the universe is expanding. Okay, real simple illustration. Kind of an oval-shaped universe here. But anyway, what happens though, think about this. What happens as you begin to back extrapolate, as the scientists say? As you begin to think about what the universe would have been like 1,000 years ago, or 100,000 years ago, or 1,000,000 years ago. You go back as far as you want, and at each step back, the universe is going to be getting smaller and smaller and smaller and smaller, until finally you get to a point where all the matter in the universe is congealed into a single point, and that marks the beginning of the expansion, and also the beginning of the universe itself. And so, contrary to the 19th century perspective that said that the universe was eternal and self-existing, and it was infinite in duration and time going back, Hubble's discovery was the first of many indicators that the universe actually had a definite beginning, in fact, a definite beginning in time. And that established now what we refer to as the finite nature of the universe. It's not infinite in time, it's finite. It has a beginning.
Next was Einstein.
Well, Einstein has a very interesting role in this story, because he's the great, the guy with the bad hair that we all know, that is the icon of science itself. And he was working on a theory called general relativity in the teens, but prior to Hubble. And as a result of this is a theory of gravity that implied that massive objects cause space itself to actually bend or create a curvature of space. And his theory implied that the universe was expanding and decelerating, as if a good illustration might be like a firecracker. You light it, you throw it in the air, it goes kabang, and then you have the paper shrapnel that first accelerates very quickly and then kind of flutters to the ground. And in other words, the implication of his theory and the math that described what the universe was doing implied that the universe was expanding and decelerating, but then if you wind the clock back again, that it had a beginning. So Einstein's theory and Hubble's observations converged on this conclusion that there must be a beginning. But the interesting part of the story is that Einstein didn't want to believe his own results. He didn't want to believe his own math. And so what he did is he posited an arbitrary value for one of the constants in his equation. His field equations of relativity, general relativity, implied that the universe was expanding. And it had to be expanding to counteract the force of gravity, because if we only had gravity, we'd all collapse into one big ball. So he posited not only gravity, but there was an expansion force, but then he posited another force of just the right strength to a contracting force that would counteract the expansion force. And that was called his cosmological constant. Now, he had no physical justification for this, no evidence to support this, but he was at the time strongly persuaded of the naturalistic, the materialistic worldview that said that the universe was eternal and infinite in time. And the idea of a beginning to the universe was just abhorrent to him. So he posited this as a kind of philosophical necessity to keep the universe static and thereby eternal in time. And he later learned that, well, he'd made a bit of a mistake on that. In fact, it was encountering Hubble that got him to change his mind again.
Einstein made up this cosmological constant, and yet later on, the evidence brought him back and showed him that he was wrong, and he admitted that he was wrong. What happened?
Well, it's a famous story. He was invited out to the Palomar Observatory in Mount Wilson in Southern California. Hubble had made these amazing discoveries about the expanding universe. He writes to Einstein and invites him to come out to see what he's seen. And there's some newsreel footage from the time Einstein goes out. He meets with these other scientists. The media is gathered there. He goes in. He looks in the telescope. This is all pre-staged, but when he comes out, he says, in his heavy German accent, he says, "I now see the necessity of a beginning." And he later announced that his fudge factor, the precise value that he set for the cosmological constant, was the greatest mistake of his scientific career, that instead of an infinite universe infinite in time, there was now decisive evidence from the heavens, from the telescopes, that there was a definite beginning to the universe, just as his theory of general relativity first implied. So he had these two strains of scientific discovery, one theoretical, one empirical, converging on the conclusion there must be a beginning, in stark contradiction to the key tenet of the naturalistic worldview that says that the universe is eternal and self-existent and infinite in time. So this is a huge challenge to scientific materialism.